Assalamu alaikum wa rahmatullahi wa barakatuh. Today we got to complete the types of the polynomial functions. In the previous lesson we studied the concept of the polynomial function, and then we studied the constant function. The constant function, it is a function from the set of real numbers to the set of real numbers, and it can be written in the form f of x equals a, where a is constant and a can be any real number. If a equals any real number except 0, the function is of 0 degree. But if a equals 0, the function has no degree. And then we studied the graphical representation of the constant function. The constant function f of x equals a is represented by a straight line parallel to x-axis and cuts y-axis at the point 0 and a. And the range of this function is the set which contains this constant, which contains a. Example, f of x equals 3. This is a constant function, and this constant function can be represented by a straight line parallel to x-axis and cuts y-axis at the point 0 and 3. That means the set of all images is 3, or the range of the function is 3. But today we will complete the types of the polynomial function. The linear function. What is the linear function? It is a function from the set of real numbers to the set of real numbers, where it can be written in the form f of x equals ax plus b, where a belongs to any real number except 0, but the absolute term b can be any real number. The coefficient of the variable x can be any real number except 0, but the absolute term b can be any real number. Example, f of x equals 2x minus 3. This function is of first degree, and any function, any polynomial function of first degree represent linear function. And the highest power of the variable x here is 1. That means this function is of first degree and it is called a linear function. Also, the highest power in this function is 1. That means it is of first degree and it is called linear function. So the linear function is a polynomial function of first degree. The graphical representation of the linear function. Example, f of x equals 2x minus 3. This is a linear function, and the linear function can be represented by straight line. But at the first, we need to make a table which contains some elements belongs to the domain and the elements belongs to the codomain. We can put any elements belongs to the domain. The domain is the set of real numbers. We can put any real numbers belongs to the domain, say 0, 1, and 2. And we need to find the image of each element here belongs to the domain. As we said before in the previous lesson, we can use the function rule to find the image of any element belong to the domain. Here, the image of the element 0, to find it, we need to replace the letter x by the number 0 in the function rule. 2 times 0 equals 0, minus 3 equals negative 3. So the image of 0 is negative 3. Also, we can find the image of the element 1 by using the function rule. We can change the letter x here by the number 1. 2 times 1 equals 2, minus 3 equals negative 1. So the image of 1 is negative 1. And to find the image of the element 2, we can replace the letter x in the function rule by the number 2. It's going to be 2 times 2 equals 4. 4 minus 3 equals 1. So the image of 2 is 1. Now we can plot these ordered pairs. The first ordered pair, 0 and negative 3. its location is here. Its first projection 0 and second projection -3. And the second ordered pair 1 and -1. Its location is here, 1 and -1. Its first projection 1 and second projection -1. And the last ordered pair 2 and 1, if we plot it, it's going to be here 2 and 1. Its first projection 2 and second projection 1. Now we can join these points by using straight line. To make a straight line, this is the function 2x minus 3. Remarks. We can find the point of intersection with x-axis if we put the second coordinate or the second projection equals 0. Again, to find the point of intersection with x-axis, we need to put y equals 0 or the second coordinate equals 0. Also, if we need to find the point of intersection of y-axis, we need to put x equals 0 or the first coordinate equals 0. Let's take an example. The linear function given the rule y equals 2x minus 1 is represented graphically by straight line intersected y-axis at the point what? As we said before, if we need to find the intersection point with y-axis, we need to put the x-coordinate equals 0 or x equals 0. So we have to replace the letter x here by the number 0. It's going to be 2 times 0 equals 0 minus 1 equals -1. So if we put x equals 0, its image is going to be -1. So the intersection point is going to be 0 and -1. Again, to find the intersection point with y-axis, we need to put x equals 0. But if we need to find the intersection point with x-axis, we need to put y equals 0. Graph the function h of x equals -half x. This is also linear function because the highest power of the variable here is 1 and it is of first degree. Here the absolute term b doesn't exist. That means b equals 0. As we said before, to represent this function by using straight line, we need to draw a rectangle or a table which contains the elements of the domain and the element of the codomain. We can put any elements belongs to the real numbers, 0, 2, and -4. And then we need to find the image of each element here. To find the image of the element 0, we need to use the function rule. So we have to replace the letter x here in the function rule by the number 0 to find its image. And it's going to be -half times 0 equals 0. That means the image of 0 is 0. And to find the image of the element 2 by using the function rule, we can replace the letter x here by the number 2. It's going to be -half times 2 equals -1. And to find the image of the element -4, we have to replace the letter x by the number -4, and it's going to be -half times -4 equals 2. So the image of -4 is 2. Now we can plot each ordered pair here to make a straight line. The first ordered pair is 0 and 0, and it's located here in the center, and it is called origin point. And the second ordered pair, 2 and -1, its location is here. Its first projection 2 and second projection -1. And the third ordered pair, -4 and 2, is located here. Its first projection -4 and second projection 2. Now we can join these points by a straight line like that. From here we can deduce that this straight line passing through the origin point. So in general, we can say that the straight line passing the origin point, if the absolute term or if b equals 0, in general, we can say that the straight line can passes through the origin point if the absolute term equals 0, or if b equals 0. Complete. The function f, where f of x equals 3x. This is a linear function because the highest power here is 1 and it is of first degree. Is represented graphically by a straight line passes through the point what? Here the coefficient of x is 3, so a equals 3, but b doesn't exist. The absolute term here isn't exist. So that means the straight line passes through the origin point and its coordinates is 0 and 0. Graph the function f of x equals 3 minus x. Here the coefficient of x is -1. That means a less than 0. A is negative. We need to graph this linear function. So we need to draw a table contains the elements of the domain and the elements of the codomain. We can put 3 elements belongs to the real numbers or belongs to the domain, 0 and 1 and 2. Then we need to find its images. We need to find their images by using the function rule. To find the image of the element 0, we need to replace the letter x in the function rule by the number 0, and it's going to be 3 minus 0 equals 3. And to find the image of the element 1, we can replace the letter x in the function rule by the number 1, and it's going to be 3 minus 1 equals 2. So the image of 1 is 2. And to find the image of the element 2 in the function rule, we need to change the letter x with the number 2. It's going to be 3 minus 2 equals 1. So the image of 2 is 1. Now we can easily plot each ordered pair here in the 2 coordinates. The first ordered pair, 0 and 3, its location here, its first projection 0 and second projection 3. And the second ordered pair, 1 and 2, is located here. Its first projection 1 and second projection 2. And the third ordered pair, 2 and 1, its location is here. Its first projection 2, second projection 1. And now we can join them by straight line. Remarks. From the previous, we can deduce that if the coefficient a more than 0, the coefficient of the variable x more than 0, that means the straight line makes an acute angle with the positive direction of x-axis, as in the previous example. In the previous example, the coefficient of x is positive. That means a more than 0. So the straight line makes an acute angle with the positive direction of x-axis. But here in this example, the coefficient of x less than 0 is negative. That means the straight line here makes an obtuse angle. This is an obtuse angle with the positive direction of x-axis. This is an obtuse angle more than 90 degrees. Let's answer some exercises. Here we have a constant function, f of x equals 2. Then we need to find triple or 3 times the image of the element root 2. As we studied before in the constant function, the set of all images equal the set which contains this constant. That means the image of any element belongs to the domain is constant, is that constant. If we need to find the image of 3 in this constant function, its image is going to be 2. The image of 4 is going to be 2. The image of any element belong to the real number, its image is 2. So here we can say that the image of root 2 is also 2. So the value of 3 times f of root 2 is 3 times 2 equals 6. because the image of f of root 2, the image of root 2 is 2. So 2 times 3 equals 6. Here also is a constant function. The image of any element belongs to the domain is 4 because 4 is constant. That means f of negative x is also 4. The function from the set of real numbers to the set of real numbers where the function rule f of x equals 5. This is a constant function and the constant is 5. Is represented by straight line parallel to, as we said before, parallel to x-axis and intersect y-axis or cuts y-axis at the point 0 and this constant, 0 and 5. Again, the constant function f of x equals a is constant, is represented by straight line parallel to x-axis and cuts y-axis at the point 0 and a, 0 and this constant. Number 4. If the point a and 3 is located on the straight line which represents the function f from the set of real numbers to the set of real numbers, where f of x equals 4x minus 5, then a equals what? If the point a and 3 belongs to the set of the function, that means the image of a is 3. F of a equals 3. So if we replace the letter x in the function rule by the number a or by the unknown a, the result or the final result is going to be 3. So I'm going to replace the letter x by the number a or by the letter a. It's going to be 4a minus 5 equals 3. It's going to be an equation, and we need to solve this equation to find the unknown a. If we solve this equation, the unknown is going to be 2. Because if we move negative 5 to the other side with different sign, with positive sign, it's going to be 5 plus 3 equals 8. If we divide each side of the equation by 4, the result is going to be 2. If we solve the equation, the result or the value of a is going to be 2. The straight line which represents the function f from the set of real numbers to the set of real numbers, where f of x equals ax plus b, intersects y-axis at the point 0 and 3. If f of 2 equals 7, then a equals what and b equals what? Since the point 0 and 3 belongs to the set of the function, that means f of 0 is 3. The image of 0 is 3. So if we replace the letter x by the number 0, the final result is going to be 3. So I'm going to replace the letter x here in the function rule by the number 0. 0 times a equals 0, so we can ignore this term. And the final result is going to be 3. That means b equals 3. And then we can use this equation, f of 2 equals 7. If you replace the letter x by the number 2, the result is going to be 7. If you replace the letter x here by the number 2, it's going to be 2a plus b, and b equals 3, as we said before. So it's going to be 2. The final result is going to be 2, because if you replace the letter x by 2, it's going to be 2a plus 3 equals 7. If we solve this equation, the final result or the value of a equals 2.